Okay, hello everyone. Here in classroom, we are getting ready. So people are picking their pizza. Okay, hello everyone. Here in classroom, we are getting ready. Hello everyone. I will start the presentation. So if you didn't have your 2 slices of pizza, you're invited to go in the back. Okay. I just have to manage all my windows. I think it should be good. So welcome to this presentation of Béluga, which is the new cluster we have prepared for you from, well, I will give you the full schedule we had. It has been a few months that we have worked on this cluster. So my name is Pierre-Luc Saint-Onge. I'm an analyst working at Calcul Québec in the McGill team. We have a larger team now with the entire Calcul Québec. We are about 40 employees. And I have a few colleagues in the classroom. Over there, Bart Oldeman. My director, Brian Caron, over here. In the back, Simon Deritou. Behind him, Pierre-Olivier Quirion. And if I forget someone, it's because you're so hidden that I cannot see you. So you are all welcome. Today we will not present all yourself because it's also online and there's about 57, 50 people listening online right now. So I will continue. Calcul Québec has financial partners. Some of them are universities, some are, others are other research labs. And we also have, is this working? Yeah. We have the RIS, Canary, which are the national network for inside the province and also inside Canada. And we have other agencies that are funding our operations. I will talk a bit about the process of getting this new cluster, which is called Béluga. We have started in June 2017 to select a site within the province of Quebec. We have decided to go at ETS, which is more a neutral site within the province. So all universities, Sherbrooke, University Laval, University of Montreal, and McGill are working together on this neutral site at ETS. In April 2018, we have published the request for proposals, which is also called RFP. This is in this document where we describe all the specifications we want for the next cluster. I will present you that in the next few slides. In July, oh, someone is not getting sound. Let me check the sound. I can see that I have sound. Okay, let me go back to the presentation. So I hope people online are getting sound, and it's just sound is okay here. Perfect. So in July 2018, we have identified a winner. Brian, can I tell the vendor's name now?
It's on our specifications list, I think, isn't it, publicly?
I'm not sure.
And yeah, you can see it.
So it's Dell. Big deal, but anyway. They were offering the biggest offer and the most interesting one. in terms of global compute power. They have started their delivery in September 2018. So they have moved compute servers and so on. What took time is the acceptance tests. They had to pass a lot of benchmark tests, and the cluster was installed mostly globally in mid-November, but it took them 2 complete months to complete all the tests. So in mid-February, we finally got access to the cluster. We took some time to reconfigure everything, to configure compute nodes, the whole network, and so on. So at the beginning of March, this is when we have started all the acceptance tests on our side and also the beta test. So some people in this classroom right now have done tests on Béluga. We thank you a lot because you have identified some problems. And finally, we managed to open the cluster yesterday for global access. And we were right in time for the rack allocations that have started today for 2019. Okay. Summary of the RFP. So last year, we didn't know if we would get AMD or Intel processors. We were open to get any of those, so we asked for Intel Skylake processors or AMD EPYC processors. We have asked to get a lot of CPU nodes. So for those of you who don't care about GPU nodes, we ordered a lot of CPU nodes. 25% of those CPU nodes are small memory. That means about 2.4 gigabytes per core. And we have also those medium memory nodes, which are also nicknamed base nodes. So on Cedar and Graham, you had about 4 gigabytes per core. Here you get 4.8 gigabytes per core. It's like on Niagara. So those are the medium memory nodes, which are called base nodes. Very few large memory nodes. I will give you more details later. As many GPUs as there are regular CPU nodes. I will show you the numbers later. So we get a lot of CPU nodes, but as many CPU nodes as there are GPUs overall. But of course, less GPU nodes. Each GPU must be the newest NVIDIA Volta V100, which is the latest technology that was available last year, and it's also the one that we wanted for artificial intelligence applications. We have requested specifically InfiniBand at 100 gigabit per second. That one, we got some pressure to allow OmniPath, but we have decided to stick with InfiniBand for multiple reasons. I will not go into this debate now. The system selection has been made by benchmarks and cost of operation. So that means vendors must prove to us that applications are running well. And we took some real applications like NAND and also Torch and also TensorFlow to make sure it will run stuff that you guys are running. We also took some micro benchmarks like Stream, which is for memory bandwidth. There is also the classical HPL, the high performance LINPACK test. And there's also another one, NAS, which is a mix of other micro benchmarks. So with this collection of 8 benchmarks, they had to test each node individually, and each node had to pass what they said it would perform. So if it's supposed to have some score for some test, it has to pass that test. And this is why it took a lot of time to complete this. Overall, for compute nodes, CPU nodes only, it's 28,000 compute cores. That's 688 compute nodes with CPUs, but we get another 172 GPU nodes, where each GPU node has 4 GPUs. So this is why you get 688 V100 GPUs. And for each GPU, you have 10 CPU cores because it's we have 40 core nodes. So we get overall 172 GPU nodes with 40 CPU cores and 4 GPUs. The network we got is finally InfiniBand EDR. This is what we asked. We also got a blocking factor of maximum 5 to 1. So that means on a single leaf switch, 20 up to 30 ports are used for compute nodes, and 6 ports are used to connect to the core switch. So you get almost a factor of 5 nodes to 1 going to the core switch. But on some switches, you get even less nodes than that. So this is why it's a maximum. So sometimes the 5 is probably less than this value. The overall project space and sketch space, we are talking about 9 petabytes for project and 2.6 petabytes for sketch space. It's on a Lustre file system. And also, we have built an archive storage of 67 petabytes. This number is more or less because it's going to grow and adjust according to the demand and the type of data we will have to move on the tape system. Please note that, like on Cedar and Graham, the project space will be backed up on tape. So it's something new, and we all like that. Node type. So these are the small nodes that I was talking about. We have only 172 of these. That's the 25% compared to the other base nodes. On each node, you have 40 cores. The memory you may request on those nodes, if you want to get the full memory on that node, is 95,000 megabytes. Please look at the documentation if you want it in terms of gigabytes. Inside a single node, you have 2 Intel Gold 6148 Skylake. So each one has 20 cores, and it's running at 2.4 gigahertz. I don't think we have enabled turbo mode, and there are certainly no overclocking. Each node has a single SSD drive of 480 gigabytes at 6 gigabit per second. So it's a SATA, it's not SAS, it's a nearline SAS. It's not that big, but it's much faster than what we used to have on Calcul Québec clusters before.
Is this space can be used as local scratch, or it's?
Yeah, sure. Yeah. So the local scratch, now you don't have access to the local scratch folder directly. You have to go into the $temdir, slurm_temdir. And this will bring you to a private folder for your job only.
That will be deleted.
Yes, and it's located in this local scratch. Medium nodes, well, base nodes, they have, well, physically 192 gigs of RAM, but the space usable is 191,000 megabytes with the same specs as the small nodes, so same InfiniBand network and so on. We only have 12 large nodes. It's not as large as the ones you can find on Cedar and Graham, but it's still 768 gigabytes. The usable space in memory is 771,000 megabytes. Again, 40 cores, the rest is the same. GPU nodes, it's different here. We only have 172 nodes of these, but each node has 4 NVIDIA Volta V100. So this is where we get the 688 GPUs overall. Same amount of memory. We tried to get at least 32 gigabytes of host memory for each GPU. So this is why we get, it's not like a small node. We try to get enough memory for you to store data on host, and then you transfer data to the GPU node. One thing that is different, the local scratch here is not 400 gigabytes, it's 1.6 terabytes, and it's using the PCI Express or NVMe interface, which is much faster than the SATA interface. So if you have GPU jobs and you're loading lots of data, you better put it on the local scratch first, and then you load your data on GPUs after. talking about GPU nodes, this is how it looks. The front is what we see on the bottom left. And then when we get in the server, we have the 4 GPUs. A bit in the back, we have those 2 Intel sockets with the 2 Intel Xeon processors. On each side, we have the memory DIMMs. And in the back, we have the power supply and all those cards that connects the server to the network. So this is how it looks. And the very high-pitched noise is because of those fans here running. Béluga is more noisy than Gilliman. Do we have a question online? No. I had a question from a user online. Is hyperthreading enabled on these CPUs? And the answer is no. So if you need hyperthreading for whatever reason, you may go to Niagara, but on Béluga, hyperthreading is disabled. So you only have access to 40 virtual cores, and that's it. Here is the topology for the GPU nodes. We used to have on some clusters a balanced configuration between CPU sockets and GPUs. Here, all GPUs are connected to the NVLink card. So if they are using the SXM2 interface. So between GPUs, communications are very fast, very quick. But between one CPU socket to this NVLink card, you only have one PCI Express at 16x speed to communicate. That means you have to be even more careful when you load your data to GPUs. But you have to think that now you may have up to 4 GPUs to compute your data. So each GPU has 16 gigabytes of device memory. And when you combine all of them, you have up to 64 gigabytes of GPU memory. So you better work with all GPUs together than trying to move data from CPU to GPU all the time. So this is one thing you have to think about. This is a very good configuration for deep learning applications. And also that depends on your application, but be careful about how you manage your data and how you transfer data between host and device. The one we have is the Tesla V100 SXM2 flavor. I will not go into details, but you have the theoretical performance you can get for double, single, and tensor performance. If we compare with P100, so those GPUs you can find on CDAR and Graham, it's roughly, well, for double and single precision, it's about 50% more performant. But in terms of half precision, it's about 6 times the performance of what you can get with P100. So if you have lots of models to train with your machine learning application, you may want to use those V100 cards. We have the 16 gigabytes version of those. In the RFP, we told them we are open to get those 32 gigabytes cards, but in the end, we got 16 gigabytes. What's the performance in practice? Earlier, I told you about 8 benchmarks. So here are one comparison. The comparison we did on CDAR, it was in December 2017. So maybe those numbers would be different now, and it was done with some configuration. I didn't do those tests myself. But here are the results that the vendor has bid when he has submitted their offer last year. So stream, we get for memory bandwidth 1.4 times faster. HPL, because we are using the AVX512 instruction set, it's 2 times faster. NAMD, again, 2.3 times faster. NAS is a mix. So roughly for CPU, it's around 1.5 to 2 times faster. But of course, we're going from 32 cores to 40 cores, and we have new instruction sets, a new instruction set in the processor. In terms of comparison with GPUs, again, it's not really fair to compare P100s to V100, but still, let's try it. NAMD with 1 GPU, so it's 2 times faster. NAMD with as many GPUs as we want, it's again 2 times faster. It doesn't scale very well, but at least using 1 GPU helps a lot. Using Torch for machine learning applications, it's 1.4 times faster. Maybe it was using the single precision, I don't know. But using TensorFlow, this is where we got a very big jump. It's even more than the theoretical 6x times faster than NVIDIA is reporting. But here, because it's n GPUs, imagine that on CDAR, we are using all those 4 GPUs connected to the same side, but they are not using the NVLink. They are using PCI Express. And maybe because we are using NVLink on Béluga, and we have also much faster GPUs, that could explain the 7.7x factor. Other results from beta testers, machine learning applications. So they did a real comparison with optimized code, both from CDAR or Graham and Béluga. So they got a 5x speed up between other national systems and Béluga. If we compare a single node application using all 40 threads, we get up to 40% speed up compared to a node on a 32-core node system. When we compare Béluga and Niagara, users should expect comparable performance. So it's more or less equal in terms of performance. So that really depends. You may want to develop code on Béluga, and once your code is ready for big time, large scale, you go to Niagara. Let's talk about the compute environment and the environment overall. Let me check the time. It looks good. So the main address to connect to Béluga, we have many aliases. So you can use beluga.computecanada.ca. If you speak French, you can use beluga.calculcanada.ca. But if you're really, let's go Calcul Québec one, you can use beluga.calculquebec.ca and so on. Globus endpoint, this one, we only have one version of it. So it's Compute Canada, # Béluga -DTM. So if you want to transfer your file efficiently, and I want to emphasize on that, you should leave Briare, you should leave Guillemin, you should leave those older clusters we have in Calcul Québec and migrate your data to either Béluga or other national systems. It's really critical right now. So please use Globus, or now, since you are able to SSH to Béluga, you can use rsync if you want, you can use SCP, but please migrate your data. Same file system structure, so everyone has a home directory. Inside your home, you should have a projects folder, and inside the projects folder, you should have a list, well, at least one symbolic link to your at least default project space. But if you have access to multiple project spaces, then you will have multiple symbolic links in this folder. In home, you also have a Scratch symbolic link. That's a link to your personal Scratch space. On Béluga, I will show you the default quotas, but Scratch is 20 terabytes, but data in there is temporary. And the default project space is 1 terabyte. We have almost the same modules that you can find in the software stack. In fact, it's the same software stack, but because we support newer versions of compilers, we support newer instruction set, well, the default modules that are loaded on Béluga is simply a newer set of modules. You may load an older set of modules on Béluga, and also on other national systems, you can also load newer modules that you can find on Béluga. I think I will. Wow, I had to click the button. Same scheduler with similar policies. So it's Slurm. And as I will show you in a few slides. Next one, please. in a few slides, it's a Slurm with the same type of partitions, like 3 days, 7 days, 3 hours, and so on. Modules. On Béluga, by default, the active set of modules is all compiled for AVX 512 optimizations. Test your code. It's possible that you will get some acceleration compared to other clusters, but it's also possible that you will get some slowdown. It will not perform as on other clusters. I will show you how to load the exact same modules with AVX2 optimization. So we have new compilers, Intel 2018 and GCC 7.3. By default, we get a new version of OpenMPI 3.1.2. We have a lot of new versions of libraries. So Bart over here and Maxime Boissonneau have worked a lot to compile lots of applications with newer versions to work on Béluga. And the standard 2018 is the default set of modules that we find on Béluga. If you want to access the older set of modules that you can find on Cedar and Graham, you have to load Arch AVX2, and then you load the standard environment 2016.4. So this will bring you to the set of modules you get right now on Cedar and Graham. Yeah, Bart?
Just one remark. There are some minor differences even with that. It's mostly about commercial software for which we don't have a license. Think about Fast and Ocean.
Good point. So I will repeat for people online. Everything that is compilable will be available, but for commercial software, it may not be available on Béluga because of licensing issues.
I also have a question.
Yeah.
So when you log in on Béluga, there's already modules available, or programs that are loaded by default, I think, from the Calcul Canada app. So, and these are not in the standard environment. Or, I mean, when you log in by default on this Béluga system, how can we know which software versions are available by default?
So the question is, when we log into Béluga, how do we know what modules are loaded?
Module list.
Yeah,
module list.
Without doing any module load,
that's
what's
because
the environment that we get, that the vanilla, when we log in without doing this module load standard environment?
The vanilla environment you get is this one, standard environment 2018.3. This is the one you get.
So this is it. When you log in, you have this already loaded.
Just
Yeah.
another question. So if I want to load the old environment, what do I need to do?
If you want to load the older environment, it's this one, Arch AVX2.
Should I do purge? Module force purge.
It's not necessary.
Not necessary with the syntax.
All right.
There used to be a purge force, and then you set the SNT variable and so on, but I believe this Arch AVX2 is doing all that for you.
This will be on the wiki.
Yes, I will find a way to publish that on the wiki share. And if you're on Cedar and Graham and you want to load the same modules you can find on Béluga, you can use module load standard environment 2018.3 on Cedar and Graham, and you will get the same modules. And I think there's a plan to have this new environment to be configured on Cedar and Graham at some point. Yeah, sorry.
So the commercial software is not available at all, or do they install later or something?
Okay, for commercial software, I think the Intel compiler is there, and that depends on what is the commercial software you are using. And for many commercial software, you have to bring your own license. So maybe the module is there, but you still have to bring your own license, and we have to open firewall ports and so on.
So the one that I'm using is with CMC licenses. So we should let you know about the licenses and then you will activate it?
Yes, we have to unlock some port in the firewall for your application. But then, Bart, is CMC installed in the software stack, or it's to them to install it?
I'm not sure.
Because before you had to go through this interface that you had set up right on the legacy systems, right? I thought the CMC stuff had
right.
there was a need
The CAD Connect and the CAD stuff like that. Yeah. So it's something we have to work on to make it work.
Yeah, you have to send us tickets like this.
So if you're using a commercial software and for some reason you cannot reach the license, like Bart said, send us a ticket and we will figure out a way to make it work. Other questions? Okay, so I will continue. Scheduler. So if you're coming from a legacy system where you had Moab, Maui, Torque, or some other systems, we are using Slurm on Béluga, and it's the same as on Ssd and Niagara. So we are using the sbatch command to submit a job script or the salop command to start an interactive job. If you're using a batch script, you have to use the #sbatch keyword before all those options you want. So how many nodes, how many processors, how much memory, for how long, and what is your account. So I have some examples here of what you should put in your job script. So at least you will have to set an account. You may define a roll time. So here it's 1 hour. Here the syntax is a bit different on the right. It's 1 hour, but you can also specify days. With Slurm, you may specify some amount of tasks. If you only specify a number of tasks, you may have processors scattered across the cluster, and you will have to use MPI to contact all your processors. But if you want all those tasks to be inside one node, then you have to specify nodes equals maybe 1 or many nodes, and then how many tasks per node you need. So, I heard why? No, that's fine. Okay. If you want to run hybrid jobs with threads, so a mix of processes and threads, you may specify for each task some amount of CPU. So this line here is for the amount of threads. So here are some examples. Suppose you want 12 tasks and 10 threads per process. You may request this. You will get 12 groups of 10 processors somewhere in the cluster. So each group of 10 threads will have to communicate to other groups through MPI. But if you want to have all processes together on as few nodes as possible, then you may request 3 nodes, 4 tasks per node. So the 12 here is 3 times 4. And again, 10 threads for your task. If you need to use GPUs, one GPU is, well, GRES is a resource here, GPU colon 1. If you want to use all 4 GPUs on a single node, GPU colon 4. Memory, if you use the syntax mem equals 0, you will get at least 95,000 megabytes on the node. So this notation here will bring you to either the small node or a base node. You don't know in advance, so you can only think that you will get at least 95,000 megabytes. But at least you have a larger pool of nodes to submit your job. If you really need more than 95,000 megabytes, you have to specify the amount of memory you want for a full base node. But if you have not requested full nodes and you have requested tasks scattered in all the cluster, then you may request some amount of memory per CPU. So this one will make sure you will have enough memory for each process across the cluster. As a suggestion, use megabytes. But if you know what you're doing, you can also use gigabytes. Yeah.
Just to clarify.
Yeah.
The terminology here of hybrid jobs is that the task is something that communicates from MPI to other tasks. And
Yes.
CPU is something that replicates your OpenMP.
In an OpenMP style, yes. Hybrid here meant mostly MPI and OpenMP, but you can also think about let's put GPUs inside of that, and let's put many different technologies. But yes, when you submit a hybrid job, I recommend that you connect to the compute node and monitor what the job is doing if all processors are running at 100%. Because if you select options wrong here, you may see that all your threads are limited to a single core. So only one physical core is running all 40 threads, so it's not optimal. So make sure that you check your job, and then you will know that, okay, I have to reserve maybe CPUs per task, and the system will understand, okay, now I have to use all those cores, one for each thread. So you have to be careful. But with SSH, when a job is running, you have access to that node.
And the name of the node is just the one that is shown on the schedule.
Yes, you can use scheduler commands to get information about your job, and then you connect to the node.
But I shouldn't have any like Canada. It's just the name. Is
yes, if you want to connect to a compute node, you can use the short name.
Yeah, you look at SQ, and then it's like BLG 5107 or
Question online about modules. Will the 2019 modules be available? Maybe at some point. The standard environment 2018.3 is the set of 2019 modules. But maybe at some point we will get newer compilers and newer versions of software. So if you need something very specific, please send a ticket, and we will see where it fits best in the software stack. Question about Matlab licenses. The status for Béluga is Matlab will be available to all academic users, right?
yes.
Yes, so because McGill owns a total academic headcount license, and because Béluga is officially owned by McGill, we have the right to share the total academic headcount license, so all academic users of Béluga will be able to use Matlab in single mode type. So you can reserve up to 40 cores for your Matlab job. Do we still have to specify CPU affinity flag to compute hybrid tasks? That's a good question, and it's quite an advanced topic for this presentation, so it's a bit out of the scope. I believe when you use the srun command instead of MPI exec, srun would probably try to put processes properly on each CPU socket. So it's an advanced question. I think I will continue with the presentation, but if it's important for you, please send a ticket and we will try to figure it out. But I think the srun would do the trick. Okay. Scheduler policies. Let me check the time. This could sound as a bad news, but we made the difficult choice of limiting people to 7 days for your jobs. On other clusters, it can go up to 28 days, but here we want to force you to use checkpointing. And if and only if you have some commercial software that just doesn't checkpoint, and there's really no way to do some checkpoints because there are tools, even if you're using a commercial software in serial mode, we have other tools that can take a memory snapshot of your process and make a dump that you can restart later. That's possible. But if you have something running with MPI and it's a black box binary, and you know in advance that your model and your simulation will take, let's say, 8 days, in those cases, with the right justification, we may allow you to run jobs longer than 7 days. Otherwise, we really want to push you to implement checkpoint and restart mechanism in your pipeline. Maximum, yeah, question? If?
Do you provide support for doing checkpointing?
Yes, the question is if we provide support for checkpointing, and yes, of course, we have a wiki page about the MTCP, and I think we have all the workshops about that. So, yeah.
And why is it? Did the Ssd and Graham team complain about longer hold time, so you decided that? Or
I think the reality is on Ssd and Graham, people were able to submit longer jobs, but then when they have to plan a downtime, it's usually 1 week in advance, and whatever job is still running 7 days later, they would kill it. So even if you submit a job that would last 28 days, you risk that we will kill your job anyway. So maximum jobs for each user is 1,000 jobs.
Is there a group code also?
No, I think what I saw this morning is like 500,000 jobs for all users. But for the group, I don't think it's really per user. We want to catch the user something too many jobs. Separate set queues. So small nodes and base nodes are in one queue. So if you submit a job, you may target either those nodes with low memory requirements. Large nodes are in separate queues, and GPU nodes are of course in a different set of nodes. So these policies could change with time and demand. This information, you can find it on the Compute Canada wiki. It's only a reminder about useful commands. So if you want to monitor your queue, what's running, so it's SQ -u with your username -t running. If you want to see what's pending in queue, what's an idle job, is the keyword pending here. If you want to see what's going on with a job that is either idle or running, you can use the command scontrol, show job. I don't know what -dd means, but then you provide the job ID here. So this will give you all the details understood by the scheduler. So if you think that your job is stuck in queue and you don't know why, you may investigate all the details in your job and see if it's blocked for some reason. Maybe it was routed to the wrong queue, or maybe you asked a lot of memory or something that doesn't exist on the system, and so on. If you want email notifications, first you have to set your email address with the mail user with your email address. And then here I have one example, and mail type begin, but there are multiple types you can define, begin and I don't know the details, but there's one keyword in case your job is failing, and so on. When your job is completed, you can get information with the sef command. You can get, for instance, the memory usage. If you believe that the memory usage is wrong, because sometimes it's not really reliable, start your job and then connect to the compute node, use stop, and check how much memory is used by your job. Another way to get information is the sact command with the -j for the job ID. So you will get lots of details. The job has started, prologue, and so on, and then the job runs, and then the job ends.
Is there a maximum amount of time after the job is completed when those commands will only work? The SF and the SF?
I'm not sure about Ceph. Maybe it's really looking at all the history, but saccount, I think if you target a specific job ID, it will remain there. It's a database that will accumulate information. But if you type saccount alone without specifying a job ID, it will look only until the previous midnight. But then you have other options where you can define from this time to this time. Let's talk a bit about security and networking. I think it's quite important. Firewall is like Graham, so a bit strict. So you need to ask for exceptions if you want to reach a licensed server. So you tell us, okay, I have to reach this IP address on port, whatever, and we will make sure it works. It's not written here, but security on Béluga, it's by ECLs, it's by access control list, where you specify which user has access to what, read, write, execute, and so on. So this is the type of security you get on the system. And I would say on top of that, but actually it's at a lower level, all disks are encrypted. So local scratch on each node, the SSD is encrypted, and the Lustre file system in behind, it's all encrypted. So when we get rid of Béluga in 6 years from now, we will see encrypted data on the disk, and that will mean nothing without the properties to decode it. We took that decision because one CPU core is able to manage 2 gigabytes, which is more than enough to write to the SSD, so it's not going to hurt your compute performance. About the main storage, all the metadata is on SSD. It's a lot of details for you, but the main storage is on disk, but all those file names, permissions, and directories, those metadata is on SSDs because we have lots of read and writes to get those small information, and this is on SSD. It's very quick. The type of redundancy, 3 copies for home directories. So we will not lose your homes. And for the project space and scratch, we have, well, 8 units of storage for data, and 3 different units of redundancy. So it's mathematical redundancy. So if we lose, we have this set of 11 blocks of data. And if we lose up to 3 copies of data, we can still work and figure out what was the real data behind. So it's quite secure. File system, it's using Lustre with ZFS. Maybe it's interesting for you. One important thing here, compression is enabled, at least on project. I'm not sure about home and others, but project space. If you transfer files from legacy systems to Béluga, you may have, let's say, for instance, 100 terabytes on Guillemin. And once transferred on Béluga, it looks like 40 terabytes. How come? That's because of the compression. So you may even pack more data on Béluga, but quotas are compared to the compressed size. So if you get a 100 terabyte allocation on Béluga and you're using only 40 terabytes of data, then good for you. Good for you, but I warn you, be careful. If you have very well compressible data, something that, let's think about a very big file of 1 terabyte full of zeros. This file system will compress it to something like a few megabytes. And if you have a lot of those files in your project space and you fill your project space with those, the day you will want to transfer those files to another system, the data you want to transfer will be 1 terabyte for each file. So we will figure out this nightmare in 5 years from now, but I warn you, we have compression enabled on Béluga, and that will probably be the norm from now on national systems.
I have a question.
Yeah.
What about performance for compression? Does it affect anything?
I think we have reached in recent years a level where compute power is more powerful than writing and reading powers. So
we do a lot of seeks and moving inside files.
Oh, that's interesting. Please.
That's one thing we do a lot.
Yes, tell us if it's hurting a lot, because I would assume there should be some indexing inside the file. It should know where to seek to reach some point in the original file. If not, of course, it's
Okay, we'll see. We'll check.
It's a good question. It's a good question. Because I don't know what's the structure of that compression. I don't know if it's just from the beginning to the end. Average compression. So we have so far we have achieved 1.37 times compression in average because some people have already compressed data. Yeah, question.
Transfer data from the Scratcher project to the Slurm temp.dir. The temp.dir on the compute node compressed also.
I don't think it's compressed. No. So the question was if someone transfers data from the project space, which is compressed, to the local scratch. I think that the local scratch is not compressed. Question online. So where should I compile my software on Béluga? This takes several gigabytes. In home directory is a good place to compile code. It depends on how much several means to you. By default, home directories have 50 gigabytes. I say by default, but this will stay 50 gigabytes. If you need to compile with more space, well, you can go in project space, or you can also go to Scratch space if you want. But if you want something that will stay, because Scratch is always temporary, then you better compile your code in the project space. So yes, if it's 10 to 30 gigabytes, then you can compile your code in your home directory. So we did some benchmark with a software, IOR. I don't know exactly what it is, but the whole storage space for project managed to write at 64 gigabytes per second and also read at 44 gigabytes per second. Maybe there was some caching here to achieve 64. For Scratch, what you have to understand about those numbers is we have a large storage system. Half of it is dedicated to project, and 25% is for Scratch. About that, and home is the rest. Well, when I said 25 and 25, these are servers that access the data, but the space, of course, it depends on the total amount space reserved for each system. But I think we have 4 servers, 4 projects, 4 modules. Yes, Bart?
Yeah, I'd just like to reinforce the point is that these are all bandwidth, but if you work with lots of small files, by all means, try to use the SSDs that are local. They're much faster than anything on the parallel file system. It's just like a recurrent thing over and over again.
Yeah.
Maybe you want to back this on.
Yeah.
Video.
So what Bart said, these are bandwidth benchmarks. I have removed the input-output benchmarks we had, and it wasn't that great. So what Bart said is the file system is really optimized for continuous reading and writing to the file system. So when you manage large files, and if you need to do lots of input-output of operations on small files or on small chunks of data, you better import that data on local Scratch on the compute node, and do all input and output operations locally on the system. What's interesting here in home directory, well, the read speed is 3 times the write speed, but that's because we have 3 copies. So the write speed, well, we write 3 copies, but to read, well, we can use 3 copies to read different blocks of data. Let's talk about cloud. Well, unfortunately, not so much. The cloud in Calcul Québec, the new cloud system is not ready, and I cannot talk about any detail at this point. But it's coming later this year. Technical support. Béluga is supposed to be supported by the Science Compute Canada team. So if you're from the province of Quebec, it will be supported by the Calcul Québec team. If for people online, you're from West Grid or from Compute Ontario, or AceNet, then you would get support by the local team. Just out of curiosity, which company was the contractor for Béluga? That's Dell. So if you want to get information about technical support, we have this wiki page, and we have the documentation page about Béluga. So the email address to contact us is support@calculcanada.ca or support@calculcanada.ca. And this will go to the main ticket system we have. And this is how we manage your request. So these are all the slides I have. Do you have any question? Yep.
I have two questions. Is the old tape archive from Gilliman, the archives we have there, is it still usable on? And the second question is, do you give some more outline about the tape system that you have installed on the Béluga? Like, file sizes and where the blocks are.
Okay, so the first question is about data on tape on Béluga, on Gilliman.
Yeah, exactly.
So these will not be connected to Béluga. So at some point, if I'm not wrong, the Calcul Québec staff will migrate that data from Gilliman tape to Béluga tape.
Okay, so
that's right.
We'll migrate it, but then it's going to be available in what's called nearline space, which is really just, you won't use the same method of interaction to request putting things to tape. It'll be all automated for putting and automated for people.
Okay, so that what was on tape on Gilliman will go to the nearline space on Béluga.
Yes.
And your second question was,
file
size on...
is it the same, like, mechanics we had on Gilliman, or is it different in terms of, maximum file size to occupy full tape and stuff like that?
It'll be automated. There's specifications regarding nearline on the Canada Wiki, which is like the allocation that people get and what they look by default. You don't have to necessarily pack. We would still encourage people to pack things, but I forget what we have in the documentation, but it's not the same level of, say, of complexity that we ask you to do on Gilliman. You will truly interact with it as a disk point of view, and then in the behind the scenes, we take care of the migration of tapes.
Just before people leave, there will be another presentation here at 1:30, but that's for you. You're all invited to stay. So it will be about...
Is the presenter here? Sebastian Barra here? Oh, you're... Okay.
You're here? Okay. People online, unfortunately, it will not presented at 1:30, but we will end this video soon. Other questions about Béluga? Yeah.
Yeah. So I noticed that I have access to multiple projects because I'm multiple projects. My group by default when I create files is my own username.
Yes.
I just wanted to know if for our various project quotas, so like for example, I have our default group project. I have a different extra allocation for the same group that has a different group name. The files that I write, if I write them as one group or another, does that go to different quotas?
Yes, right now it's the case. Okay, that's another problem we got from Cedar and Graham, and also because we have not the version of Lustre that supports quotas like we had on Gilliman. So the question is, by default, when you connect to Béluga or Cedar or Graham, your group ID is your personal group ID. And when you want to write files in project spaces, files must be owned by the proper group IDs to get accounted to the proper quota. There is a command, I'm not sure if it's there in Béluga, it's called new group, and then you choose explicitly the group you want to use from that point. Okay. But even if you don't use that, when you CD inside the project space, there should be proper permissions, like the sticky bit for the group, that should force the proper group for that project space. But what happens is sometimes you have application that will screw up things, and then it will start writing new files with your personal group, and then you will hit some quota, which is like 2 megabytes, because it's the quota for your personal group. Your user group. So if you have such application, then your only option is to use the scratch space, and then you fix the group IDs, and then you move stuff. Yes, and I think if we're lucky, we should be able to update Lustre at some point and fix that GID problem, the group ID problem. And if you write something in one project folder, it will have the proper group and the proper quota. I'm just checking if there's a question online. What about purchase extra tape archive? I would recommend that you send an email to support@computecanada.ca, and we will pass this request to our directors, and they will be able to answer you. Could we access HTTPS external service in a SBatch job? I don't have that answer. I don't. If from a compute node we have access to external resources using the HTTPS protocol, which means port 443. I can't remember
I thought the proxies set up allow for web communications like that, but if it's a non-standard port, then they have to poke holes in the firewall.
Okay.
We have to poke holes in the firewall at the request.
Okay.
So I believe yes, but they should write in.
Okay, as much as we know, HTTPS should be reachable from compute nodes. Login nodes, there's no limitation, but from compute nodes, it should be there. If not, send us an email and we will see what we can do. I see that it works in the shell, but in the SBatch job, so maybe it's blocked. So send us an email at support@computecanada.ca, and we will see what we can do about this problem. You're welcome. Any question?
Yeah. So we had dedicated nodes. What would happen to those nodes? Do we then migrate to?
These ones will, once Gilman is migrated, those will be migrated and integrated within the Huawei nodes. It's not the legacy nodes.
No. So we have kind of the same thing with PRA. We bought these head node or login node. And I was said that it would not be migrated to the new Béluga server. So that's one thing. But the second thing is it possible for us to buy such a login? Because we're working mostly.
Second question, answer yes.
Okay.
First question is more difficult because it depends on the mixtures of technology we can't mix too many technologies because it becomes increases complexity.
2 years ago, based on the original. I don't know what's the.
Yeah, I think we have to talk together with Jean-François and to see what's feasible.
Okay. I have a couple of questions like this. Maybe we can.
There are some accommodations we can do for people having integrated hardware to legacy systems. That depends on when your project has started. But if you have personal needs, send us an email and we will see that. There was other questions. Yes.
About nodes on Béluga. So for those groups who have dedicated nodes, how the access and allocation is going to be implemented? Is it going to be default allocation or is it going to be separate allocation?
I think it will.
There'll be separate allocation, just like people who have storage. So in your case, you refer to it as dedicated, but we call them integrated because they're within the pool. So there's an allocation that gets created within the Compute Canada database. So it does not become part of your default. Your default is there, regardless of whether or not you've integrated, but then there'll be a separate allocation created in the system that represents the portion you've integrated within.
When can we expect this to be?
Well, right now, particularly in the Béluga case, will be occurring when it's integrated. Your current nodes, for example, are integrated. The purchase, depending on the case, for example, the ones that existed on Gilman, when it gets migrated to Béluga, that's when it gets integrated. The new nodes, we have not put the new nodes yet into Béluga because we had to go through the acceptance phases that Pierre-Luc was describing earlier.
So they're already not?
No, because we had to compartmentalize between the main purchase from I would say, a legal and logistics point of view. We had to compartmentalize that specific installation. Now that we're there, we're going to move to the next step now of adding the integrated nodes that have been purchased thus far.
How long will it take?
I'd have to give you an estimate. Probably we'd be looking at within the next the shutdown, so you'll probably within the next month and a half, 2 months.
And meanwhile, we can access everything.
Gilliman is still there for the next, we didn't touch on this month, one longer, the storage for at least another month for people who are using it generically. Contributed people will be there for longer, depending on how long it takes us.
Okay, so contributed hardware and to Béluga may come in the next 2 months, approximately. Yeah, question?
On the compute nodes, you're saying that the SSDs are 480 gigs,
Yes.
and these are like private, and they're shared space. So if I have
Yes.
someone on the same node as me and he decided to upload 400 gigs of alignment files or whole genomes or something, my script expects to have 200 or 300 gigs also. How do I know the quota and the space, and I have to program this in my Python to know how much room there is so that everything doesn't go completely.
Yes, that's a problem. I'm not sure if our colleague have implemented some reservation for storage, and I don't think the scheduler will actually check what's inside.
I know I'll have to check it myself, so I'm wondering if there's a command for this quota on that before I start transferring files. Because if I start transferring files and it runs out of this space and goes completely to someone else, more stuff. How do I dig in with that?
Right.
Send the ticket, then we can give you the right commands to dig. It's not integrated within the normal space quota checks that we have right now, because those don't take into account locally.
The problem that one user locally is seeing is the local scratch on Béluga compute nodes is shared. Of course, your Slurm temdir is private because it's private to your job. Only you have write access to this folder. But the partition itself on the SSD is shared. So if you share the node, suppose you have 2 different jobs, even from yourself, you could have 2 jobs on the same node. So the node is shared, so it's like there's no limit right now, I think, that is implemented.
Yeah, well, at least if I would put it in the pipeline, at least to check this quota to know how much space is there, even for myself and other users on there. At least I won't transfer 400 gigs of stuff. And
I think you can use DF.
Will it say the DF of the whole disk or only the
If you provide the path local scratch, DF on local scratch, it will load the space for that partition.
For the whole disk? Okay. Not only my shared?
But for the whole partition.
Shared.
Because the disk, I think the disk could be partitioned to have multiple partitions, and some are used for CVMFS and other services. But the one for local scratch is a dedicated partition. So, other question? Yep.
So, graphic user interface, is it accessible just like Unimint or not?
You should be able to use VNC. And by default, I assume that we will get the same mate desktop environment by default. So if you want to use graphical interface, X11 should be supported, and also VNC. Question in the back?
I just checked about Matlab. It was previously in
Right. We would have to check for what if we can install it, if we have the right to do it. Yes, but we have to check the terms of the license.
We may have to check if we need to restrict to McGill staff on Béluga. We have technical means to do it.
So for Mathematica, otherwise you can bring your lab license if you have one, but if it's from one university, then we have to check and do something about it.
Are you at McGill? Yeah. Okay. I think it should be possible as on.
Yes.
I don't know if it's a relevant question for you guys, but is there a possible way to shift the allocation from Ssd Drive to Béluga?
At this point, I don't think it's possible because probably all CPU allocations are at the very limit of the capacity of each cluster.
Because when we applied, I mean, Béluga was not using.
Oh, I think oh, maybe here is what happened. You were in a fast track case this year, and I think I clearly made a note to move you to Béluga. But then when they gather all the requests together, they have to put people and try to have the best fit for as many research groups as possible. It's a very heartbreaking operation because they have to cut research groups. And maybe the best fit they found for you is to leave you where you were. So
It's technically like you're in Simon Fraser University cluster, modern cluster.
yeah, I don't know what happened.
Well, we can see what we've typically tried to do is if people have integrated the systems already, we try and place allocations with integrated systems.
Yes, that's their case.
So
which group are you on?
Physicist view.
Okay.
They have Huawei nodes. Of course, you
we
will get.
can look as follow-up. It's sometimes good to have external allocations elsewhere just in case. But I understand we usually try and put them together. But I think because Béluga wasn't available, this is probably why, as you said, that didn't.
Yeah. Something failed in the process.
We can look into it.
We can send us an email.
Well, I have a question. It's more personal for our group. We're planning on buying a dedicated server or service material and software for the M&I, and we want to know if it's possible to integrate this into the Béluga structure. So
maybe it's a bigger
We've
project.
had some discussions with people at the M&I previously about similar types of things in those projects, so we can have a discussion offline to see what something makes sense.
Okay, the question about CPU allocation is some groups have a split allocation on CDAR and Graham, and they were asking if they could migrate their allocation from one cluster to the other. For example, to merge the allocation or to simply migrate from CDAR to Béluga, for example, and that's not possible. Okay, I think I will end this YouTube presentation. So thank you for your presence. I hope it was helpful. So see you next time. Bye.